day everyone, we are the Group 5. I am Frank Saise, along with my group mates, Kaderao, Day, and Seaton. Come and join us as we going to tackle about carbon steel.
Had to cut her off, it was painless. Show me fake love, it was shameless. I should've known that we would never make it.
Before we proceed in our topic, here's our objectives for today's lesson. First, our classmates should be able to learn what are the physical properties of a carbon steel. Second, they should be able to learn what are the heat treatment process for common carbon. And lastly, they should be able to learn the suitable heat treatment process for common carbon steels given by the properties required. Mapapaisip ka talaga kung ano tong carbon steel. So let us know first what is carbon steel, which is Kaderao is going to discuss it to you guys.
My name is Melvin Brimpi Kadirao. Carbon steel. Carbon steel is a kind of steel containing amounts of elements carbon which you perhaps recognize from other domains of study as a very common and versatile atom. Steel is not a metal but an alloy or mixtures of metals. Carbon steel can be classified into three categories according to its carbon content: low carbon steel or mild carbon steel, medium carbon steel, and high carbon steel. Low carbon steel is the most widely used form of carbon steel. These steels usually have a carbon content of less than 0.25 weight%. They cannot be hardened by heat treatment, which is not form martensite. So this is usually achieved by cold work. Low carbon steel has a properties of low hardness and cost, high ductility, toughness, machinability, and weldability. Low carbon steels are often used in automobile body components, structural shapes such as L-beams, channel and angle iron, also pipes, construction and bridge components, and food cans. The medium carbon steel. It has a carbon content of 0.25 to 0.60 weight% and a manganese content of 0.60 to 1.65 weight%. The mechanical properties of this steel are improved via heat treatment involving austenitizing followed by quenching and tempering, giving them a materialistic microstructure. Medium carbon steel has a properties of low hardenability, medium strength, ductility, and toughness. As a result of their high strength, resistant to wear and toughness, medium carbon steels are often used for railway tracks, train wheels, crankshafts, and gear and machinery parts requiring this combination of properties. And the last is high carbon steel. High carbon steel, as their name suggests, are steel with high carbon content. It is very difficult to cut, bend, and build. Once heat treated, it becomes extremely hard and brittle. Hard carbon steel has a properties of high hardness, strength, and low ductility. And this is the examples of high carbon steel: rolling mills, rope wires, screwdriver, hammers, wrenches, and bandsaw.
Good day everyone, my name is Falconer Day. Now I'm going to tackle about the heat treatment processes along with my group mate Frank Saise. Now let us know first what is the purpose of heat treatment. So the purpose of heat treatment is to soften the metal to change the grain size, to modify the structure of the material and relieve the stress set up in the material. There are various heat treatment processes for carbon steel, and these are annealing, normalizing, hardening, austempering, martempering, and tempering. The first is annealing. Annealing is a process for softening material or to bring about requires changes in properties, such as machinability, mechanical or electrical properties, or dimensional stability. There are four different types of annealing process of steel, and these are spheroidizing, full annealing, process annealing, and diffusion annealing. Spheroidizing. Spheroidite form when carbon steel is heated to approximately 700 for over 30 hours. The purpose is to soften higher carbon steel and allow more formability. These are softest and most ductile for form of steel. Full annealing. Carbon steel is heated to approximately above the upper critical temperature of 550 to 650 for 1 hour. Here are the ferrite transformed into austenite. The steel must be cooled in the realm of 38 per hour. The result in coarse pearlite structure. Full annealed of steel is soft ductile with no internal stress. Process annealing. The steel is heated to the temperature below or close to the lower critical temperature of 550 to 650, held at this temperature for some time, and then cooled slowly. The purpose is to relieve the stress in cold work. Carbon steel with less than 0.3% weight carbon. Annealing. The process consists of heating the steel to the high temperature of 1100 to 1200. It is held at the temperature for 3 hours to 20 hours, and then cooled to 800 to 850 inside the furnace for a period of 6 to 8 hours. It's further cooled in the air to the room temperature. It is called isothermal annealing. That's all.
Once again, I am Frank Saise, continuing the topic, normalizing. It is a type of heat treatment applicable to ferrous metals only. It helps to remove impurities and improve ductility and toughness. The purpose of normalizing process is to improve machinability, to modify and refine cast dendritic structure, also to refine the grains, and to make the material suitable for further heat treatment.
Hardening. It is done to increase the strength and wear properties. One of the prerequisites for hardening is sufficient carbon and alloy content. Hardening heat treatments invariably involves heating to a sufficiently high temperature to dissolve solute-rich precipitates. The metal is then rapidly cooled to avoid precipitation. Often this is done by quenching in water or oil. Tempering. It is a heat treatment that is applied to ferrous metals, most notably steel and ductile iron, like medium to high carbon ferrous metals, which produce a metallurgical structure called bainite. It is used to increase strength, toughness, and reduce distortion. Mark tempering or mark quenching is a form of heat treatment applied as an interrupted quench of steels, typically in a molten salt bath at a temperature right above the martensite start temperature. The purpose is to delay the cooling for a length of time to equalize the temperature throughout the piece. This will minimize distortion, cracking, and residual stress. Tempering is carried out by preheating previously quenched or normalized steel to a temperature below the critical range, holding and then cooling to obtain the desired mechanical properties. It is also the most common heat treatment used to improve hardness and toughness in steel, as well as to reduce brittleness. And that's all. Let's now proceed to the next topic that will be discussed by Sito.
Heat treatment process for carbon steel based on its properties. First is the low carbon steel. Steel with low carbon has properties similar to iron. As the carbon content increases, the metal becomes harder and stronger but less ductile and more difficult to wield. The process heat treatment is carried out first by heating the metal and then cooling it in water, oil, and brine water. I have an example to you, the process of heat treatment for low carbon steel. So here is the steel. It has been treated. Then they put it in the water. The hot steel was put it in the oil or the brine water. Second is the medium carbon steel. Representative samples were subjected to heat treatment process, which are quenching, formation, and tempering. The steel was heated to the austenizing temperature of 830 Celsius and water quench. Again, I have an example of the heat treatment process for medium carbon steel. So after forming and tempering, they quench it in water. Lastly is the high carbon heat treatment. The high carbon steel part has been exposed to a massive thermal envelope pushed to 820 Celsius. The hot workpiece is fully transformed into an austenitic state. And in quenching, they usually use oil. Again, I have an example of the heat treatment for high carbon steel. The steel was heated to 820 Celsius, then they quench it in oil. Oil is much slower than water in reducing heat. They use oil usually because oil is a third traditional quenching agent suitable for high-speed steels and oil-hardened steels, and in fact for any steel for which the required degree of hardness is achievable. Oil has a slower rate of cooling compared to either water or brine, but faster than air, making it intermediate quench.
That's the end of our lesson. I hope everyone learned something from our topic. Thanks for watching and God bless to all.